Everybody knows the May 11th aurora was a big event, but how big was it? It's estimated that it was one of the top 20 events in the past 500 years. This timeline shows when those storms took place. The bigger the dot, the farther south people could see the aurora. Why was the May 11th event so powerful? Not surprisingly, a lot of things had to come together. And in order to explain it, we have to look at the cause of it, the sun. The sun is a star. It's made up of super hot electrified gases that are bound together by strong magnetic fields. The magnetic fields and the plasma perform a complex dance that we see at the surface of the sun, looping and stretching, looking a little like a pot of fast boiling water. The most active areas are usually associated with groups of dark sunspots. The magnetic field lines can stretch out too far and break, snapping a little like a rubber band. When the magnetic lines snap, they can launch huge bubbles of plasma and magnetic fields out into space. This is what solar scientists call a coronal mass ejection, or CME. The snap is usually accompanied by brilliant flashes of high-energy light called solar flares. If the CMEs are launched in the right direction from the sun, they can hit the Earth's magnetic field and cause a geomagnetic storm. The amount of magnetic turmoil on the sun follows an 11-year cycle. During what scientists call solar minimum, there are very few sunspots, and the sun's magnetic field is quiet with very little twisting and turning. But during solar maximum, there can be frequent and large sunspots. During this time, the sun's magnetic field can churn constantly, shooting out frequent CMEs. And now we have all the elements we need for the monster geomagnetic storm that struck the Earth on May 11th. First, we're approaching a solar maximum right now. The sun has been very active this year with frequent CMEs. Fortunately, most are not aimed at the Earth. But during the week preceding May 11th, a giant sunspot group wider than almost 16 Earths formed and began producing solar flares and CMEs. Beginning on May 7th, the giant sunspot group spit out 4 CMEs in quick succession. The sunspots were in just the right place on the sun to send those CMEs in the Earth's direction. However, CMEs can be launched at different speeds, ranging anywhere from 60,000 miles per hour to over 6 million miles per hour. In this case, the 4th CME was the fastest and quickly overtook the other 3. This combined all of their plasma and magnetic fields into a giant CME, or what is sometimes called a Cannibal CME. This is what blasted the Earth's magnetic field on May 11th for the extreme geomagnetic storms and the incredible display of northern lights. At least 3 more slower CMEs blasted out of the sun that week, and they maintained the auroras at a much lower level for another 2 or 3 days, but not like what we saw on May 11th.